Oh man, there we go. There we go. There's the shot. Good morning, good afternoon, good evening. Hope everyone's happy and healthy. Michael Khan, how are you, mate? Does that troll need a timeout from the very first get-go? Hope everyone has bring their listening ears today, because it's going to be another special debunking show. Apologies, just got to clean the lens there. Hope you all heard the show yesterday, the special show about the Equinox, and how the Equinox has definitely it's become what the globers would like to call a globe proof, but it's definitely anything but proof for the globe. It is a bastardization of what we see in reality, and then you need to go back into imagination land. You need to convince yourself that a compass is lying to you. And then you can jump into the imagination land of the globe with magnetic declination, and the true north is the geographic north. Yeah, it just doesn't work. If you've missed that show, go back on my live stream yesterday. It's titled Equinox Sunrise. Equinox sunrise does not rise at the east. That's not what we saw. Hey, Schumann TV. Hey, Level Up. Sleeping Warrior, how are you, mate? Plain truth. Definitely not a dating stream, Travis. Plain truth. Man, Travis never gets old, does it? I'll tell you what could be a dating stream is, well, not a stream, but a dating app. The Sun Moon Zodiac, the Flat Earth Sun Moon and Zodiac app. And download the Flat Earth Friend Finder. And that can be your new dating site, because it's got all flat earthers. Yeah, obviously I don't know, I've got wife and children, but it's just good for finding friends. Some would use it for organizing get-togethers, groups. PJ Cookshank, how are you going? Ex-heliocentric, I love that name, ex-heliocentric, because that's kind of sums up everyone here, doesn't it? We are all ex-heliocentric, aren't we? I'm pretty sure, well, I wouldn't put my money on, but I think most people here once believed in the globe. I don't think anyone here was born knowing that we lived on a flat earth. Well, our senses definitely told us that we lived on a flat, stationary, enclosed earth, but over the years, we've obviously been broken down, brainwashed, conditioned into believing, because you have to believe that we live on a globe. There's nothing that we can do in reality to prove to ourselves that we live on a globe. And that is just reality. Everything that we see presents itself as flat, enclosed, and stationary. Oh, and I might get into the meat of the subject today, because it's another debunking one. Yeah, the globe is just the anti-flat earthers. They can't get enough of these flat earth schools. They just can't pull themselves away from it. It must be some sort of a hypnotic viewing experience for anti-globers, because left, right, and center, I'm getting videos tagging me, Mitchell from Australia. Hey, look at this. This is globe proof. Yeah, Mitchell from Australia, you're an idiot, says Mr. Sensible yesterday, after he couldn't string two sentences together that were coherent, that didn't contradict each other. WA, great views, thanks. All right, let's get into it, hey. I'll start with who we're dealing with here today. It's this bloke here. His name's Wally. Some people would remember the cartoon series Where's Wally, also books. And obviously this bloke's name must be Wally, because he's named himself Where's Wally, and dressed up in his little outfit, and he thinks he's going to give us some globe proofs. Jay Savvy, Jay Savoy, greetings from Canada. How are you, mate? Bree, good evening. This is who we're dealing with today. And I just want to start with the premise. When you're calling yourself something, it might be his actual name, Wally, but when you're calling yourself a YouTube channel, Where's Wally? That is the YouTube channel that I'm getting this video from today. Who's tagged me at Mitchell from Australia. Look, come look at this. Come look at me. Mojo Shop. How are you? Daily Jacobson, thanks for being here. What does a Wally even mean? It's an insult that became popular in the 80s, meaning an idiot. So to refer yourself as a Wally, yeah, he's definitely going to prove himself as a Wally today. I'm going to refer him to as Bloody Wally today. All right, let's get into it. Now, what? All right, so he's seen Mr. Sensible's, the debunking of Mr. Sensible that I put out, and that's the premise that he's starting with today. So without any further ado, just make sure the volume's up, screen sharing. All right, this is Wally's video that I'm about to go through today.
Oh, g'day everybody. Where's Wally here? Well, this one's going to be special. Mitchell from Australia, he tried and failed to take down some very special globe signs brought up by Mr. Sensible in his cheeky little claim for Dirth's bitcoins. Of course, Dirth didn't have any intention of ever paying up. So the one that I really liked that Mr. Sensible brought up was the measurable fact that the two tropics are equal length, but yet both are shorter than the equator. It's a perfect globe sign. Now, let's hear how Mitchell deals with this.
Number 16, the Tropic of Capricorn. On a globe Earth, the tropics of both Cancer and Capricorn would have the same circumference. On a flat Earth, they can't possibly be. Number 17.
Oh yeah, so the Tropic of Capricorn.
Yeah, a circumference, you say, and that is working or not working on a flat Earth. I'll just go back to that. So what are you comparing it to, Mr. Sensible? Are you trying to set up a false dichotomy where we're using some sort of a globe projection, the AE map, to compare to your globe Earth, and you're trying to say which one is more accurate, and you want to come out on top with the globe? You're gonna need it after that, are you, Mr. Sensible? And you're gonna have to make me claim that we have some sort of a map to give you, some sort of circular map that we can measure the distance of this Capricorn. I'll just show you the beach. So the sun's about to come up. The sun is up somewhere over there, and it's all about the sun. The tropics are all about the sun. Capricorn and Cancer are just the extremities to where the sun's GP will move throughout the year. Yeah, they're just arbitrary points. Nothing to do with a globe. Definitely works on a flat Earth. It is just the GP point to where the sun is. Moving on.
Well, there was a lot of ducking and dodging there, Mitch. Well, we all know that you FE lot will not reproduce a map because, well, yes, this is a dichotomy. It just ain't a false one. Now, only one map will work, and you lot are admitting as much by not producing one anymore, because you don't want anyone to test it, do you? Also, you admit that...
So not producing a map. I'm not sure if Wally saw my live stream the other day about maps. Hey Arwen, hey Adam Meakin, how are you guys? Oxbow Spirit, Buddy Roll, thanks for turning up to another edition of Flat Earth School. Just another debunking video here from someone who's trying to debunk me. They're screaming for attention here, and this guy's first point was that we do not have a map. We do not produce a map because we're apparently scared that it's going to be debunked. No, that is far different to this claim. Needs to be reconstructed because we definitely have maps. Google Maps, Near Maps, every map that we use for navigation, for layout of the land, they are all flat Earth maps. Measuring anything that goes onto a map in real life here, using planar surveying, has to start with the premise that we are on a flat level surface. That's how you measure angles. That's how surveyors use their instruments. They need to first assume that they're on a flat level surface. Now,
Again,
I'd like to just replay this video from Nathan Oakley. I think he did a great job of how to deal with someone who is claiming that maps take in consideration the globe. This is how you deal with a fundy that makes that claim.
Times a charm. So you can show drop on a map then. You could show how high a mountain was, and with your colour coding, you could show that there's an area below it lower than it. So you can show drop in two-dimensional maps. Do you have Earth curve drop, 8 inches per mile squared, coloured in your map?
Can I answer now, or are you still talking?
What, my specific question with an end and a pause to it? Do you have drop on your map? You've already answered no. You've then said it wouldn't show drop. I've pointed out the maps do show drop. You've said they've got colour coding. So do you have the colour coding for Earth drop or not?
I have the color coding for elevation, not for Earth curvature.
So no drop then. No Earth curve drop. Just topography. No drop. Flat.
Exact. No, it's not correct.
So flat then.
So flat then. Yeah, that's how you have to conclude. Is there any curvature in any maps? Is there any elevation drop due to the curve of the Earth in any map? Yeah, one of the globe trolls in the chat is saying, how do you present 3D drop on a 2D map? Have you ever heard of contour lines? Have you ever heard of that thing? Michael, I think he needs another timeout because it's the same troll that keeps coming in, asks the same damn questions, and I keep asking him the same question. Please produce a map that takes into consideration the globe and curvature. Thanks, Michael. Awesome, mate. One of my awesome moderators, one of my awesome Patreons. We need a map from you Globers that takes into consideration anything to do with the globe, that takes into consideration curvature. Yeah, drop 8 inches per mile squared. It is definitely capable. Maps are definitely capable of showing drop. Yeah, of showing the elevation change. Contour lines. Yeah, an area that is lower than another area. Definitely capable. So, what is the claim from Wally? That we don't have maps? No. Every single map that we use for anything in reality, whether it be for navigation, whether it be for Google Maps, all of these maps that we use in reality, layout of the land that we can use for navigation, they're all flat Earth maps. None of them take into consideration any curvature. They don't consider any globe when making these maps or portraying these maps.
So your map doesn't show Earth curve. Your map is flat, but it's definitely capable of showing it. It just doesn't have any.
So how could...
So why are you asking me something? So you don't have any Earth curve in your map? Don't ask me something.
I've not met a single cartographer.
Don't tell me who you've met. Just confirm you haven't got drop in your map.
I don't.
Well, so it's flat then. No Earth curve, no 8 inches per mile squared then. Why the hell are you believing you're on a sphere when there's no sphericity in your map? So, no Earth curve drop in your map. Now show me one that does have it.
I can't show you.
So no map shows Earth curve? They're all flat then? Hello? Do you need the White Knight to help you? Or are you done? Are you done?
I answered your question.
Yeah, you told me how flat your maps were, even though they have elevation profiles. Yeah, they can show drop, but they don't show Earth curve drop. Why would they? Well, because it's drop that's capable of being depicted, and it isn't. Which one's got it? None of them. So they're all flat. Why was it that you think you're on a sphere again? Because you were told?
Yeah.
Go and tell the people who told you they're wrong.
Go and tell the people who told you that you're on a globe. They're wrong. That's the conclusion you need to come to. Show us. That is what you need to provide, globe believers. If you make the claim that maps, yeah, they take into consideration curvature. They take into account the globe. No map that exists for the layout of the land, for reality, for navigational purposes. None of them take into consideration any curvature, and they are definitely capable of showing it. You can use the elevation tool on Google Maps, draw 1 point over here, 1 point over there, as far as you want. Get the elevation profile, no drop at all, no 8 inches per mile squared. Where can we see the curvature, globe believers? Definitely not on maps. Definitely not looking out of the horizon. Definitely not from any height, any altitude in our world, as Neil deGrasse Tyson eloquently stated when he was reviewing some footage of Richard Branson's space tourism 58 miles up. He did some calculations. He doesn't think we're going to see curvature so we're never going to ever see curvature in anything. Yeah, do you understand that, globe believers? So everything, Google Maps, a flat earth map that we use daily, hourly, minute by the minute for getting around in our cars, for knowing where places are. Yeah, it is all flat earth maps. Near maps, what do I use? Another flat earth map. The maps are just detailed, the navigation on the road, flat earth maps. Yeah, elevation profiles showing a flat earth beneath our feet. All you're going to see is the elevation profiles. Never ever will you see a map with curvature taken into account. 8 inches per mile squared. How is that something that can just be left out of maps? Especially when these elevation profiles, they need to be measured in the first place. Yeah, surveyors, do they take into account any curvature? Definitely not. Yeah, so this is what you need to take into account if you're living on a globe. 8 inches per mile squared, that should be measurable. It should be on your maps, but it's not. Never on any maps, is it? Every single map that we have is a flat earth map. So, Wally, this is proof that we have flat earth maps. Yeah, stop saying, globers, that we do not have any flat earth maps. I think it's the globers that need to produce the maps. Oh, that was his first point. So yeah, he's off to a flyer. So we'll continue.
Also, you admit that the tropics are defined by the extents of the sun's GP, but then you totally contradict yourself by saying that they're arbitrary. You need them to be arbitrary, don't you, Mitch? The thing is, Mitch, we don't even need your space pizza map because the globe map matches exactly what we measure. Now, we can measure the tropics, and we find that both are actually shorter than the equator when it's measured. Now, Jervis Bay is where you like to hang out, so let's go and use that, shall we? Mitch, if you measure the east-west line between the point perpendicular and Chinaman's Beach, well, the distance is 10,172 metres, or in kilometres, that's 10.172 kilometres. Yes, we divide by 1,000, hey Nathan?
Why would you divide a meter value when trying to come up with a larger value? Dividing something makes it smaller.
The change in longitude between those two is 0.1118 degrees. Now let's do the same thing for Kalala Beach and Plantation Point, a north-south line, and the distance for that is 6.673 kilometres, and the change in latitude is 0.060 degrees. So why am I banging on about distances?
Well, it's obviously not because you're going to be measuring curvature over those distances, Wally. Are you going to use the elevation profile in the maps to see how much curvature there is over those distances? Yeah, none.
Well, we know that flatties trust Google Maps for short distances, like when we see too far, black swan proofs and so forth, don't they? Well, if you divide the distance by the degrees, you'll see something interesting. So for the north-south line, we divide 6.673 by 0.060, and we get 111.2 kilometres per degree. 111 kilometres per degree, so far so good. So let's do the same for the east-west line. So that's 10.172 kilometres divided by 0.118, and it comes out as 91 kilometres per degree. That's 20 kilometres less. How are you going to explain that, Mitchell?
Please explain.
Let's look what happens at the Earth-Swaya runway paradox. At that latitude of minus 54.8, the east-west ratio is almost half of the north-south ratio. Now here's a clue, Mitch. cos of 60 is 0.5. But Mitch, I know you're going to want to explain this globe proof away, but you're going to need half of that. In fact, when you plot all the...
What was that, Wally? You're gonna need half of that. I saw a comment the other day saying, under no circumstances give any flat earthers any sound bites. You're gonna understand why after this, Wally.
major north-south runways in the world, and I found over 500 of them in a database, the ratio versus latitude looks like this. But when you plot all the east-west runways in the world, and I found about 1,300 of them, the ratio versus the latitude looks like this. Are you getting it now, Mitchell? If you don't have a good grasp of R by now, Mitchell, then you're going to make a huge mess when you're in continents like Australia, Africa, South America, unless you have a strong R hold. Now, don't even think about saying that the degrees are arbitrary either, Mitch, because they have meaning. Now, if you pick...
The degrees have meaning, do they, Wally? Yeah, that is fascinating. Yeah? Don't even think about it. So what he's done there, so he's got a map out, obviously a flat earth map, as we've just established. He has got some physical measurements between 2 points, and then he's looked at the values on these maps for the latitude and longitude, something that has been built in after the fact. What is a latitude and a longitude? So let's start with the prime meridian. The prime meridian is an arbitrary, yeah, meaning it could be chosen to be anywhere. So it has been done before. The prime meridian has been changed many times, many times of your latitudes and longitudes. Yeah, the thing that you say, don't even say it's arbitrary. They have meaning. What is the meaning? Longitude is the measurement east-west of the prime meridian. Longitude is measured by imaginary lines. If that's not an arbitrary thing, I don't know what is, boy. Yeah, it is just points on your map that you built in after the fact, like magnetic declination built into maps to deceive you. Yeah, so you've got a physical measurement, Wally, and then you've divided by the degrees difference over that distance, over that physical measurement. Yeah, you can't start with a physical measurement and then divide that by arbitrary points on a globe. Another reference here, what are latitude and longitude? Latitude is the number of degrees north or south of the equator, the imaginary line that runs horizontally through the Earth. Longitude is the number of degrees east or west of the prime meridian, an even more imaginary line because it was made up. This is I'm not making this stuff up. This is online. This is on National Geographic, yeah? And even longitude is an even more imaginary line because it was made up. Don't I dare say that it is arbitrary, Wally? Absolutely arbitrary. You can make it up for any point on Earth. Yeah? Anyone could go in and say, at this point, it is worth 3 unicorns. At that point, it's worth 10 unicorns. So the difference between it's going to be 7 unicorns. How do you explain that on a flat Earth? Yeah, that's the level of argument that you are using. Obviously, yeah, we can use it for GPS, but what is GPS, Wally? Does GPS take into account any consideration of a globe? No, it doesn't, as we're going to learn in one of these next videos.
So here's the thing I wanted to explain. GPS operates in a 3D Cartesian coordinate system. It is not latitude and longitude. That latitude and longitude comes from a conversion from that box style system. That's the native coordinates coming out of a GPS system. So here's the thing I wanted to explain. GPS operates in a 3D Cartesian coordinate system. It is not latitude and longitude. That latitude and longitude comes from a conversion from that box style system. That's the native coordinates coming out of a GPS system. So here's the thing I want.
That is Jesse Kozlowski detailing what GPS is. Yeah? Not latitude and longitude, Cartesian coordinates. So when you say GPS is used for navigation, it is nothing to do with the globe. Yeah, Cartesian coordinates, a box system, like a cube, X, Y, Z values, as Jesse Kozlowski has just detailed. Nothing to do with a globe. Everything to do with flat, level lines, straight lines here, put into a 3D. Yeah, and how do these boxes line up on your globe? They don't. They overlap. They need to overlap. There are many, many Cartesian coordinates on our Earth, and this is what is used for GPS. Not latitude and longitude, so don't say that we need latitude and longitude on your maps to distinguish where we are. No, they're just arbitrary, as we've just established. Yeah? Now that you understand that, why are you using arbitrary points on a map, latitude and longitude, to say that something is a certain distance from each other? Yeah, just stick to the physical measurements, not the arbitrary points, Wally. All right, let's go to the next claim. So what has he claimed in this next part of the video? It is quite extraordinary, and I went through it yesterday, all about the equinox. And before we get to that, he's shown this picture here. What happened to the tilt of the Earth, Wally? Why are we showing cartoon pictures of a globe in space with the sun? Yeah, parallel rays coming. Where's the tilt of your Earth, Wally? That was so important yesterday for the equinox. Yeah, that's why the equinox happened. No, nothing to do with that. It is all to do with the deception. The image that you put up, this image on your video that you put up, where's the tilt of the Earth that causes the seasons and the equinoxes? And yeah, it's not needed, is it, Wally? You definitely don't need it. Let's play a little animation of what you do need. Why am I picking up globe believers on their own rhetoric? Why do globe believers not even know their own model? This is what something that you should have been showing, Wally. What am I correcting you right there? See the tilt of the Earth? Yeah. Why are you showing pictures with no tilt of the Earth? Is it because it is not needed, Wally? Yeah, it's an arbitrary thing. It's a deception tool.
Because they have meaning. Now, if you pick any line of longitude, the sun will rise at the same time anywhere along that line on the day of the equinox. We all know this. Now,
what? Let's just hear that claim again, because
because they have meaning. Now, if you pick any line of longitude, the sun will rise at the same time anywhere along that line on the day of the equinox. We all know this.
We all know this, do we, Wally? Any line of longitude on the equinox is all going to see the sunrise at the same time. All right, let's pick St. Petersburg. Yeah, 30 degrees east longitude. We'll go down to, where is it? Kigali in Africa, 30 degrees east latitude. Sorry, longitude, 30 degrees longitude. And I'm not even going to try to pronounce that place in South Africa, 30 degrees east longitude. And let's consult time and date, yeah? That place in South Africa. You can verify this for yourselves. What time's the sunrise? 5:47 a.m. Yeah? 5:47 a.m. on the equinox. To the next location, Kigali in Africa. 5:49 a.m. 2 minutes difference. Yeah, okay. All right. Well, it's kind of close. How about St. Petersburg in Russia? 6:43. Now, obviously, there might be some daylight savings time, so it's probably 5:43. But they all do not line up as the same time, Wally. You bloody Wally. Huh? What was the claim again?
Because they have meaning. Now, if you pick any line of longitude, the sun will rise at the same time anywhere along that line on the day of the equinox. We all know this. Now,
we all know this, don't we, Wally? Just looking at time and date, just looking at what we can actually see in reality. Did any of those places on the same longitude as you claim see the sunrise at the same time yesterday on the equinox, Wally? No, none of them did. Yeah? Your claim is bunk, mate. The claim of the Equinox as being a globe proof is absolutely bunk. You don't see the sunrises at the same time on the same longitude. For one, longitude isn't even in existence. It is just arbitrary, as I've shown. And number two, we don't see the sunrises at the same time on those longitudes. Yeah, you can go and look this up yourself. You can verify this for yourself. All right.
Equinox. We all know this. Now, if you were to take, say, 1,000 drones and spread them all out along that line and had them all take off as the sun rised and have them all track the sunrise west, how far would they be in 1 hour?
A 15 degree per hour drift.
Thanks, Bob. But the distances would be all different, just as we saw. The drones at the equator would fly the furthest distance, and the further the drones are from the equator, in either direction, north or south, the shorter the distance they need to fly to move 15 degrees west.
So, the claim here is that if we put 1,000 drones up, that we track the sunrise, that they're going to move different distances, 15 degrees an hour, is the claim? Yeah, 15 degrees an hour?
The drone leaves the roundabout of the rotating reference frame and enters the inertial reference frame. From the rotating reference frame, it appears that the drone is deviating. Movement. But we can see that the drone is not moving at all. It's the rotating reference frame of the roundabout moving underneath the drone.
Yeah, so if we just launch our drone into the inertial reference frame, if it was a spinning globe beneath us, the globe would just move beneath us. We wouldn't even need to track the sun. Yeah, because you'd go up, you'd look at the sun would stay absolutely still, and the earth would turn underneath. That is Coriolis effect. That is just what you described, Wally. And do we see that in reality? Do we see a drone being launched and it just appears to drift away? Does the earth rotate underneath the drone? You just need to launch your drone, look at the sun. The drone and the sun would stay exactly the same. Yeah, the sun would not be moving. It'll be the earth moving underneath.
So, if we observe these things, the sun, the moon, and the stars, which are already in the inertial reference frame, from the inertial reference frame, they should never, ever move, because it's the earth turning under them that's making them move, right? But this view is from a drone in the inertial reference frame, viewing the sun, which should also be in the inertial reference frame. This sun should never, ever observe to move. But as you can see, the drone gets higher and the sun disappears. This is because the sun is actually moving, not the earth under.
So what do we see in reality, Wally? Do we launch drones, and due to the rotation of the earth, the drone appears to whiz away? Because that's what you said would happen. Yeah, in your example, we wouldn't even need to push the forward stick to go and track the sun movement to keep it in the same reference frame. No, if we had a rotating reference frame beneath our feet and we had a drone launch off that rotating reference frame, it's no longer attached. It's now in the inertial reference frame. The drone would not be seeing the sun moving. And we, here on Earth, on the rotating reference frame, would see an apparent drift of the drone. It would be moving, apparently moving. Do we see that, Wally? Do we launch drones and see drift? No, never. Yeah, so your example of tracking the sun with a drone, different distances, it is bunk, mate. You can do it in your globe paradigm.
Again. You and your reference frames have been ruined.
And what are we told by Simon Dan?
Again. You and your reference frames have been ruined.
And that is a firm statement. Launch that, globe believers. You and your reference frames have been ruined. We do not have two reference frames, do we? No, we never see it. We only have the one reference frame. Not a problem for flat earthers. A big problem if you believe you're on a globe. Yeah? All right, let's continue. So I think Wally was just making some comments up until this point, and now he's going to give us his 8 globe proofs, or signs that he says. I don't think he even calls them proofs. I think he refers to them as signs.
Are you sick of me yet, Mitch?
Oh,
I'm not done.
I think everyone's sick of you, Wally, but we'll continue.
So hold on for more proof of R.
It only works on the globe.
Number 7, satellite TV dishes, each of which point to fixed points in the sky, which are the locations of the broadcast satellites in geosynchronous orbits.
Awesome. So we've got a claim of orbits. Are you going to prove that we have orbits in the first place, Mr. Sensible? Because that is being the question fallacy. Orbits have never been witnessed. Orbits have never been proven.
Okay. Wally, I'll just stop it there because let's talk about orbits. Yeah? Let's talk about the thing that you just left out in the Mr. Sensible debunking video. Don't think we need sound on that, but this is what came next that you did not show, Wally. Yeah? What did I use to debunk orbits? Satellites? Satellite dishes? Yeah? The balloons, mate. Yeah? Orbits absolutely beg the question, Nathan. They have never been proven. They can never be proven. They will never be proven. An orbit is an imaginary concept. Nothing ever orbits anything in our world. Yeah? We have balloons for your little proof of satellites. That is what you failed to show in that little video with Mr. Sensible there. The debunking of my debunk? No, mate. You just need to show the actual debunk that I gave. You don't need to cut it off. All right, let's continue.
Chatting, comparing our RGB keyboards.
This is my new Corsair
Oh
keyboard.
God, this is
Look how
with
cool
what?
it is. It's just awesome. It's just awesome.
And I had a brilliant idea. So I said, Wolfie, I have a brilliant idea. I went on to ask him if geostationary satellites would be visible at midnight using one of his fantastic telescopes. He said, sure, the sunlight would reflect off them and you can see them. I said, but what about midnight on the night of the equinox? He said, oh, good thinking, Wal. That's a brilliant idea you just had.
That's a great conversation between you and Wolfie. When I talk to somebody, I usually get them to actually talk, Wally. How about you get Wolfie to come on and give us these brilliant ideas? Yeah? When I get people to talk, I usually ask them to actually talk. Yeah? And what are you going to need for the claim of a geostationary satellite, something that orbits us?
You're going to need R for that.
Yeah, from DRTRH. I don't quote people. I get them to quote themselves. What are you going to need if you have a globe claim, if you have orbits? What's the first thing you're going to need, Wally?
You're going to need R for that.
Yeah, you're going to need R for that, as you quite eloquently stated previously, and I'm going to use these sound bites, mate.
So let's have a good hard look at this video he captured on the 13th of October 2020. Firstly, you see all the stars are stationary as the telescope is on a polar-aligned EQ mount tracking at
15 degrees per hour.
Thanks, Bob. As the satellites move into position, Wolfie stops the tracker, so the geostationary satellites are now stationary with respect to the surface of the Earth, and it's now the stars that are moving. Now remember, Mitchell, geostationary satellites have to be above the equator. So here we are literally seeing them. So what was that claim of yours?
Orbits have never been witnessed. Orbits have never been proven.
Well, looking at the satellites in orbit is an orbit being witnessed. So there's globe sign number.
So looking at a light in the sky is an orbit being witnessed. Yeah, that's what the claim just was just then. Looking at a light in the sky is an orbit being proven, an orbit being witnessed. What's the lights in the sky? Wally, have you proven what the light in the sky actually is? Because I've got a great explanation for what these satellites are. Remember, the loons, yeah, the Satelloons, the thing that you left off in the debunking of Mr. Sensible's claim that satellite dishes prove something to do with orbits. Does that look like a satellite to you, Wally? Because this is what they use. This is what they point their little antennas to, if they need to. If it's anything other than ground-based. The Satelloons, providing internet coverage to remote areas. Yeah? Why don't you put that in your little debunking video? Why did you leave that out, Wally?
For that,
And Wally, what are you going to need if you're claiming a globe proof? What are you going to need if you're claiming something orbits around your globe?
but you're going to need half of that.
What was that, Wally? You're going to need half of that.
But you're going to need half of that.
Yeah, Wally, you're going to need half of that, mate. You're going to need the radius of the Earth. Something's been thoroughly debunked. Any globe claim, you are going to need the radius in the first instance. If you don't have a radius, you do not have a globe. You do not have a globe claim.
Number one for you. Globe sign number 2 is the satellites blinking out when they, in turn, pass into the Earth's shadow.
Don't worry, not on camera. It's all good. I blocked you out. Just some nice people walking past there. Some lovely locals.
But you're going to need half of that.
Yeah, you're going to need half of that, Wally. You're going to need half for any globe claim that you have. Yeah?
But you're going to need half of that.
Oh, Wally. Let's continue.
Earth's shadow. Well, here's globe sign number 3. As this only happens around the time of the equinox, when the shadow is straight above the equator at midnight. At other times, the shadow is either too far north or too far south, and it misses them. Now, watch again carefully as the geosynchronous satellite that is moving in from the north to the south, as it touches the edge of the shadow briefly. It blinks out for only a few frames. Well, let me show you what the shape of the shadow is likely to be at that point. Wow, that is very penumbral, isn't it?
So we've got a claim of a shadow of the Earth. Yeah, a penumbral claim. I'm not sure if you can. Yeah, I think it's a bit too glary. But what are we going to need?
You're going to need half of that.
Thanks, Nathan. Thanks for stepping in and showing that if you're claiming something like a shadow being a physical shadow from something like a globe, what are we going to need?
No.
You're going to need half of that.
Yeah, we're going to need half of that, aren't we, Wally?
But you're going to need half of that.
Thanks for confirming that, Wally. You're definitely going to need half of that if you're claiming something that is a globe proof, something that is a shadow from a globe. What are we going to need, Wally?
But you're going to need half of that.
Mate, why can't anyone produce this R-value? Where is it? Where has it been? When will it be shown? The R-value, the radius of your globe. Is it ever coming? Has it ever been proven? No. That's why we keep repeating. And that's, you get it, Wally. You yourself say, you're going to need half of that. Yeah? What was that little quote, Wally?
But you're going to need half of that.
You're going to need half of that. He understands. He understands the predicament he's in. And he's trying to preempt the argument that I'm inevitably, and me, it's not just me, it's every flat earther needs to put this forward. Any globe claim needs the R value. It is the easiest way to debunk any globe claim. Yeah? If you have a globe, you're going to need a radius. Where do you get your radius for? Yeah?
Now, let me show you 4 videos, all taken in the last few weeks. And what you will see is that the time of the eclipsing, the time that it's blinked out, is getting longer and longer as the date gets closer and closer to the equinox. It's like the shadow is getting bigger and bigger or something. Are you thinking what I'm thinking, Mitchell? I hope so.
It only works on the globe.
Are you understanding that there is a huge circular-shaped shadow in the midnight sky? What are you thinking could be the blocking object creating this?
Let's ask Adam Meakin.
Yeah, you're gonna need half of that.
Yep, you're going to need half of that. Thanks, Adam. Appreciate, mate.
But you're going to need half of that.
Thanks, Wally, for confirming your understanding that if we have anything to do with a globe, a shape of a shadow, you're going to need...
But you're going to need half of that.
Absolutely. Thanks, Wally. Thanks, Adam. Do you get where this is going, Globers? I think before you put any globe proofs forward, you need to show us the R value, the radius of your globe. Otherwise, we're just going to keep repeating these claims. Even yourself, Wally, you say, we're going to need R for that. Because you know, you get the dirty little secret out early, you're going to need R for that. Because you know we're going to hold you to that. Any globe proof needs the radius of the Earth.
I think that's globe sign number 4. Well, Mitchell, the only debunk that will be accepted here is when you image the geostationary or geosynchronous satellites at the time of the equinox and show that they are not being eclipsed or not diving into the Earth's shadow. So there is another R here too, Mitchell. Globe sign number 5 coming right at you. So if you look carefully from one day to the next, you'll see that the background stars have moved. So I grabbed a frame from each video at the point they were blinking out, and I did a plate solve using astronomy software to tell me exactly where the camera was pointing in each case. Now, if you subtract those two angles and correct for the difference of the position on the frame and the difference of 50 seconds between when the frames are taken, you get an angular change of 0.9723 degrees. Now, what would you expect the daily shift of the zodiac to be, Mitch? Well, the Earth circles the Sun in 365.25 days, so let's say 360 divided by 365.25 is 0.9839 degrees. Ooh, that's just 1/100th of a degree of error. I'm going to call that a win. That is less than 1/40th of the width of the moon. That's kind of cool. So it seems we can also measure and prove the R of the orbit of the Earth around the Sun.
So now we've gone to an R value for orbits around the Sun. Why don't we first prove the R value for the Earth that you think you're on? Sleeping Warrior?
You're going to need a force for that.
You're going to need a force for orbits. And what else are we going to need?
But you're going to need R for that.
Thanks, Wally. Thanks, Sleeping Warrior. You guys are awesome. It's great that people understand the things that we need before we claim these things. That's just the fundamental principles of what you need to show. The proof, the standard that we require to have any evidence of a globe. Do you understand yet, Wally?
Oh, Mitchell, I'm not done yet. These eclipsing geostationary satellites are an absolute goldmine for globe signs. I think this is number 6. Who's counting? Yeah, I am. So what I've been doing in the last few weeks is every time Wolfie sends me a video from last night,
Whoa. Hey, family-friendly show. We're not going to show you videos from Wolfie from last night. Yeah?
In the last few weeks is every time Wolfie sends me a video from last night, I plot the length of the eclipse as measured from the video. And here is the time as the independent variable, naturally, and time as the independent variable. Oh, Anthony's brain is going to explode with that. I can just hear him now going tick-tock, tick-tock. What we see here is a beautiful trend line with...
Let's just go. What did he just say? Did he have two... Yeah, he flashed independent and then dependent on the screen. But what did he just say?
The video. And here is the time as the independent variable, naturally, and time as the independent variable.
So time as the independent variable and time as the independent variable. He can't even get his own hypothesis right. Number 1. Yeah? So I'll give you the benefit of the doubt that you meant time as the dependent variable and time as the independent variable. This is just such a cluster screw. Man, like, why do I even need to go into this? Why do you think you're having any science in here when you have the independent variable, the same, that the cause, that's what needs to be the cause, as the same as the dependent variable, the effect? So time causes time. Is that what you're saying, Wally? Time is not a cause. Time is merely a concept. Concepts cannot cause something. Yeah? So number 1, that the independent variable the thing that you're manipulating has to be a thing. It has to exist. It has to be able to be manipulated. It has to be natural, and it has to be observed. Yeah, they're just things you need for doing science. Yeah, Nathan says, what next? Traveling that concept? Yeah, you're going to travel time? How are you going to manipulate time? How are you going to even show us time, Wally? Is that possible? Aaron says, measuring space-time is a physical process, says the rumpus. Measuring space-time is a physical... Is that one of his latest quotes, is it, Aaron? Wow. This is fantastic. All right, we'll continue. We'll get through this.
Oh, Anthony's brain is going to explode with that. I can just hear him now going tick-tock, tick-tock. What we see here is a beautiful trend line with a regression coefficient that's almost 1. Isn't that sweet? And the line is a polynomial of the second order. Oh, sorry, Mitch, that means it's a circle. The shadow is circular, and I guess you'll need an R for that. I guess that's globe.
I'm glad Wally ended on that. I didn't have to get the other soundbite out. He's just giving us another soundbite. I guess you're going to need R for that. Yeah, they like to get their dirty little secret out. Just to hand wave what we're going to say. Yeah?
You're going to need a force for that.
But you're going to need R for that.
I'm glad you understand.
But you're going to need R for that.
I'm glad you understand the situation that you're in, Wally. I'm glad you say that we're going to need R for that. Why haven't you given us R yet? Why you keep giving us these globe proofs or signs that you say? He doesn't even say proof. I don't think they can say proof anymore. He's saying these are his 8 globe signs. Adam Meakin says the amount of assumptions required to turn satellite positions into R proof. Answers on a postcard. Flat Earth School. Oh, man. It's hilarious that they're giving us these sound bites. You're going to need R for that. Because they know what our response is going to be. Any globe proof needs the R value. It is simple as that. Okay, there's 2 more.
And I'm still not done. Let's have a look at the angle to the north. So the image that I plate solved was taken in Perth. But did you notice the declination of the image was 5.5 degrees north? I bet you did. I also bet you, Mitch, that if you used a bit of maths, you could calculate the height of the satellite. Well, we know that the image was taken in Perth at a latitude of minus 31.95 degrees. We know that R is 6357 kilometres. So we can bung all that into a triangle calculator and find that A is 3364 kilometres and B is 5394 kilometres. Now we can find C by subtracting B from R and we get 963 kilometres. Just one more equation and we have H estimated for the angle we saw these satellites at. And the estimate of the measurement is only 3.666% off. That's globe side number 7, Mitch.
Yeah, I think I need to pause it right here. Yeah, this is probably my favourite one that he's given us. So he's talking about the distance to these satellites here. So you've got an observer here measuring an angle. He understands that you need a flat baseline to measure angles, but where is your flat baseline going, Wally? 90 degrees to your globe Earth should be out here somewhere, but you know you can't get 90 degrees on a spherical surface. So what's he done? He's put, so this line here is meant to be the height of the satellite. Where's it ending? In a couple of 100 miles beneath the surface of your globe Earth? Exactly, Nathan. Where did he get?
You're going to need R for that.
Elijah, just repeat that.
Well, you're going to need R for that.
Wally?
But you're going to need R for that.
You're going to need R for that. And you're also going to...
We can bung all that into a triangle.
You're going to need to show us on your globe, on your sphere, why is this 90-degree angle going under the surface of your globe? It should be out here. They absolutely know that to measure an angle here. So he's measuring an angle to the satellite to try and measure the height, the distance above the globe Earth. But why have you got the baseline running through, making a chord through the curved Earth? Yeah, this is a massive, massive problem for you globers, isn't it? You can't even you can't even put that 90-degree value, yeah, the geographical position of the satellite onto a globe. Yeah, this is meant to be a distance value. It's meant to end here, the height above the Earth, but no, you keep going. You make it end down here. It's because you know you cannot put a 90-degree angle onto a curved surface. This is the kind of people we're dealing with here. Yeah? They still think that they can measure an angle on a curved surface. You're going to need R for that, and you're going to need a 90-degree angle for that. That's why the sextant works, because we're on a flat plane. Why do you need to put this little curve in here? Yeah, it just doesn't work. It's just like, yeah, you know you need a 90-degree angle. You know that's a fundamental premise to measuring an angle to something. You need to have a flat baseline, and if you're asserting something has a distance above that line here, yeah, you know it's going to be 90 degrees. Why do you put it, the overlay of the curve, in the, why is that 90-degree angle in the middle of this bloody curve here? It needs to be here, and you know that you can't put it there. That's why it's all the way in here, isn't it? Yeah? It's ridiculous that the lengths that these anti-flat earthers go to try and prove their points. Yes, you're absolutely gonna
need half of that.
All right, so obviously, Wally, you haven't heard about the number one flat Earth proof, yeah? The sextant, the thing that you use for celestial navigation for hundreds of years that you absolutely need a flat baseline for. We'll end the video. We'll get through it. We'll end the punishment.
I know, Mitchell, what you're going to say about this. You're presuming R. Well, fair cop. I am kind of presuming R in this case. But Mitch.
So yeah, we've established that, Wally. We know you're presuming R. You haven't given us any evidence for the radius value, and you know it. So you had to get that little dirty secret out, and you think that's a win.
Well, you're going to need R for that.
Thanks, Elijah.
But Mitchell, did you know that I could take multiple measurements of this given satellite from multiple locations and work backwards and calculate R? I bet you didn't realize you could do that. So that is how easy it would be to do. And the only assumption that would be required would be that the height of the satellite is remaining constant.
That's not the only assumption you're going to need, Wally. You're going to need to assume. Yeah, this is the number one flat Earth proof. You're going to need to assume that you have a flat baseline for any angle on a flat Earth. Whoa! Jonesburg has just super chatted me 100 knock. Truth is truth. Thank you, Jonesburg. I really appreciate it. Smash the super chat. If you have enjoyed my work today, if you have enjoyed my Flat Earth Schools any other day, please smash the super chat. Sign up to Patron. I've got a really good special guest for coming up this Friday or Saturday if you're in Australia. We're talking about refraction. We're talking about what refraction is and how it is used or not used to see things, what it really is. It's going to be great. So sign up to Patreon. You're going to see that live. I will replay it, obviously, but if you want to interact with me and my guests, please sign up to Patreon, and you'll see us live. And so, Wally, what are the other things that we need to assume when measuring angles? Yeah, what is an angle? In Euclidean geometry, an angle is the figure formed by two rays called the sides of the angle, sharing a common endpoint called the vertex. That is the vertex right there, with two straight lines. That line there is your Earth using the sextant looking out at the horizon. Yeah? You don't have a radius value, so we have to assume that we are looking out at a flat surface. Yeah, that is the only reason why a sextant works. It only works on a flat Earth. It does not work on a globe. So in geometry, an angle can be defined as the figure formed by two rays meeting at a common point. The angle is represented by that symbol. Yeah, the only way you can get a degrees value. Angles are measured in degrees. Yeah, using a sextant or a protractor in that case. Only works on a flat Earth. And what is a right angle? In geometry and trigonometry, a right angle is an angle of exactly 90 degrees, corresponding to a quarter turn. If a ray is placed so that its endpoint is on a line and adjacent angles are equal, then they are right angles, yeah? You need to have straight lines for your right angles. There is no two ways about it. Yeah? As Johnsberg just detailed, truth is truth. You cannot bastardize a 90-degree angle to have a curved baseline. No. And you can't say that when we're looking out at the horizon, somewhere out there, that the horizon is refracted. You need straight lines to the horizon, because you're saying that we have a bendy line, a refracted horizon. It's game over for the globe. That's why it's the #1 flat earth proof. That's why the sextant has absolutely, unequivocally proven, physically measurable, that we live on a flat earth. And this is what we get from the sextant. We can use the sextant to measure an angle. This is the observer point here. We measure an angle to something like the sun. We'll call this the sun. We know this is the only radius value that we can distinguish. Yeah, the distance from the GP point of the celestial body like the sun, straight line down to the GP point. We know how far away we are using the sextant, using the angle. 3 straight lines here creates an area of equal altitude. And when we use multiple areas of equal altitude, see the 3 parallel lines? Yeah, these stars up here. So if that's 3 different stars, their GPs are all parallel, meaning that not only is the Earth flat, the baseline that you need, the sky is also flat. Yeah? All those stars we have to treat all those stars as if they were the same elevation. But they're obviously not a physical elevation. You cannot do trigonometry to get distances to these stars. It just doesn't work, because you can absolutely get a distance from the GP point, where it's 9 degrees above your head, to your observer point. You can absolutely go out and physically measure that. You can take your boat there. You can see how long it takes. You can see how far you've traveled. The thing that the globers like to say about this is, if we extrapolate, if we calculate the height of these stars, they're going to be different. The stars are not physical things. We just have to treat what we see in the sky as if it was its own flat plane. It doesn't have a distance. It is only apparent. That's what angles are. They're only apparent. That's what we measure. They're not a physical thing. But they can absolutely be used to, #1, traverse a flat earth. #2, to prove a flat earth. #3, to measure the flat earth. You need the flat baseline. You need areas of equal altitude. This is how we have proven our flat earth, Wally. Please go to my video titled the #1 flat earth proof on my channel. It's got about 10,000 views at the moment, Wally, and do a debunk of that. Tell us how the #1 flat earth proof proves the globe, or doesn't prove flat earth. Can you do it, Wally? That's what I'd like to see. I'd like to see it from anyone. Debunk the #1 flat earth proof. Yeah? This is a little video from, this might be a bit too glary, but I'll put it up anyway, from the US Navy, how they have been using the sextant. This is many decades ago.
If he observes the altitude of a star at a certain time, he will obtain the same altitude as will another observer who is on the opposite side of the geographical position or subastral point of the star and is at the same distance from it. If we view this diagram from above the star, it is evident that any observer at the same distance from the geographical position would observe the same altitude at the same instant. If the navigator observes 2 stars, he establishes 2 circles, one about each star's geographical position, at one intersection of which is the location of the ship. This is the principle of circles of equal altitude.
We're not making this up, Globers. These are your references. These are from your own rhetoric. Yeah, that's from the US Navy. That is from, you can call it global references, but they absolutely know that they need a flat baseline. That the angles can only work using a flat baseline. It is the #1 flat earth proof, Wally. Okay, I think there's a little bit more of your video, just to say that...
Well, thanks, Mitchell. This has been fun. I look forward to you doing a debunk of all of these points, and I hope you use my video as fodder for one of your most delightful sitting on the beach moments. See.
Well, I've just realised your your hopes and dreams, Wally. I hope it lived up to all of the standards, everything that you thought it would be. I really appreciate everyone in the chat. I've got, what is it, 54 in the chat right now. I really appreciate you guys being here with me at this. I'm at Greenwell Point today. Just a nice little harbour. Didn't see the sunrise this morning because there was obviously being physically blocked by land. Something that can never be achieved by the horizon. Yeah, shout out to everyone in the chat. Shout out to all the anti-flat earthers, says Multi-Town. She'll read my comment, says Arwen. Arwen, can you... To see reflection of the simulated person on a simulated video screen within a live video simulation was a genius setup to make it all seem more realistic. Thanks, Arwen. Thanks for your critique of my very glary screen sharing. I'm trying to find the balance between a nice scenery here and being able to screen share. Thanks for your little critique there, Arwen. I really appreciate it. Gary Weinberger says that's the same reason you can do latitude lines from sun angles, Polaris angles. They are perspective angles. My bet is they're all equal altitude. That's what we have to treat everything in the sky is. Yeah, all equal altitude. All in the same flat plane above our heads. Now, it doesn't have to be a physical flat plane. We just have to treat everything, all the celestial bodies, like we're treating on Earth, all flat and level. Two parallel lines. You got the parallel line of the flat Earth. You got the parallel plane of the celestial bodies, and that's how we measure angles between them. Arwen says Flat Earth School is the class where you don't actually want it to be over. Yeah, I appreciate it, Arwen. I'll just show you the location that I'm in at the moment. Got some mangroves over there, got just people launching their boats, people getting out fishing. Somewhere you just want to be. I think I've got I thought there was a turtle in the water, but no, it's a rock. My apologies. I really appreciate everyone being here. Thank you for joining another special edition of Flat Earth School, where Globers like to tag me in their videos. That was Where's Wally? The bloody Wally from Australia that thinks he has given us some globe signs that has been thoroughly debunked once again. Yeah, great blue skies this morning. I haven't seen chemtrails for a couple of days. It has been absolutely brilliant. Michael Kahn, I know I'd skeeve off home to go Flat Earth School. Arwen says, is springtime now arriving in Australia? Oh yeah, it's definitely into spring. Like here in Australia, before the Europeans settled here, the Aboriginals had many different seasons. It wasn't just the 4 seasons that we traditionally know. It's not only just spring, autumn, summer, winter. There's wet seasons, there's dry seasons, there's so many different seasons here in Australia. It's amazing, but it is going to be a beautiful day here on this part of the Flat Earth School that I reside. Another beach outing, I think, for the family today. Just enjoying our natural Flat Earth School around us. That's what I encourage everyone to do. Just get out in your reality around you. Experience your Flat Earth School for you, because it is the best teacher that we can ever have. I can sit here and talk to you all day, but it is nothing compared to what our natural reality can teach us. The Flat Earth School. So in conclusion, if you feel like the Earth turns on you, turn to Flat Earth School. It is around us 24/7 since the beginning of existence. I've been Mitchell from Australia. I'm not a teacher, just a student like you in this beautiful Flat Earth School, learning every day. If you like my work, please sign up to Patron, smash the super chat. I really appreciate all the support. Until next time, guys, go and experience your flat earth score around you.